Hello class, Miss Emami here. Today we are going to have another lesson in our trigonometry unit, and today we are going to look at some word problems and see how what we've learned so far in terms of finding unknown sides and angles can be used in terms of real world application. So first of all, we are going to have some definitions. We are going to talk about what is the definition of angle of elevation and angle of depression, and then we are going to look at some word problems. Now, trigonometry can be used when we want to measure the height of an inaccessible object. So if we have a tree, we have a pole, we have a building, a cliff, a hill, a mountain, we can use the concept of trigs and angles to measure and find unknown heights or depths. And in order to do that, first thing is that we need to define what is called angle of elevation, or the other name is angle of inclination, and angle of depression. Okay, so let's say, drawing has never been my strength. So the first thing we want to talk about is the angle of elevation. So let's say we are planning to figure out what is the height of this tree. What is the height of this tree? So we think about string being connected from the eye of the person who is looking all the way to top of the tall object. So think about this being a string from the eye of the person who is looking all the way to top of the tall object, and this is the horizontal line. And please understand that all standing tall objects are always perpendicular, like they make a right angle with the horizon. This angle, when you are looking up, to look at the top of a tall object, is called the angle of elevation. So this is considered the angle of elevation. Now we can also talk about angle of depression. This is exactly the opposite. Let's say you are standing on top of somewhere, like example on top of a hill or on top of a mountain, or you are on top of a building and you are looking at something below. For example, let's say you are on top of a hill and you are looking at a boat which is going on a lake. So again, this is the line of sight. Imagine a string being connected from your eyes to an object you are looking downwards. So this time you're looking downwards, and again this is the horizontal line. Okay, this is the horizontal line. This is considered what we call the angle of depression. So angle of elevation is when you're looking up. The angle between your line of sight and the horizontal line, and angle of depression is when you are looking down. So let's look at the steps that we need to follow in order to solve some real world word problems using trig. So first thing is that you have to sketch the triangle. If they haven't given you if the problem hasn't given you a sketch of the problem. So that's number one. Then you have to label everything. Every given angle and given side, you have to label them, and you also have to give names to your vertices and sides. So you give variable names to the sides of your triangle, and then when you get there, you have to find what is unknown. Are you trying to find an unknown side, or are you trying to find an unknown angle? So you will do your labeling in terms of the adjacent, hypotenuse, and opposite, and then you will set up the trig ratio, so katoa, the same way we did in the previous lessons. You substitute the known values and then you solve for the unknown value. So let's start with an example. So here is a tower similar to our CN Tower in Toronto, and you are standing 20 meters from the tower. So as a person, this is the bottom of the tower. You are standing 20 meters from the tower, and the question says that the angle of elevation is 40 degrees. If you remember the definition, the angle of elevation was the angle between your line of sight and the top when you look up, and the top of the tall object. So this is your angle of elevation, and the question is telling you that it is 40 degrees. Okay, the question tells you that it is 40 degrees. So now we are going to build our right triangle. Remember that every standing object makes a 90 degree angle with the horizon. And what we are trying to figure out, the unknown, is the height of the tower. So what we are trying to find is actually this height. I'm calling it X as an unknown. So the first step is to give names to this triangle. So I'm going to call it triangle ABC. The known angle is angle 40, so I'm going to label. This is the opposite. This is the adjacent. And opposite the right triangle is hypotenuse. And now, what we want to find is the height of this tower, which is considered the opposite side, and what we have is distance between the person and the tower, which is the adjacent. So now we are ready to write our ratio. Again, so katoa, we're dealing with opposite and adjacent. That means we are going to use toa, tangent. So tangent of 40 degrees equals opposite over adjacent. Tangent of 40 degrees equals opposite is the unknown, we substitute with X, and adjacent is 20. Now we put this over 1, and if you remember, we cross multiply. So 1 times x, 1x equals 20 tan times tan 40. 1x is the same as x, so we use our calculator and we say 20 times tangent of 40. 16.8. 16.8, and because this side is given to us in meter, this will be meter as well. This is a word problem, so you need a concluding statement. Now, I'm sure you remember this symbol from previous grades in high school. This symbol means, let me remind you about it, means therefore. Therefore, the height of the tower is approximately 16.8 meters. Okay, let's move to another word problem, another example. The angle of depression from the top of a castle to a boat is 25. Okay, now angle of depression, if you remember, means when you are looking down at an object. Okay, if the boat is 500 meters from the base of the castle, how high is the castle? So imagine someone standing here and they are looking at this boat. If you remember, the angle of depression was the angle between the line of sight and the horizon. Okay, so that means this angle here. So don't make a mistake and call this the angle of depression. It's when you look down between the line of sight and the horizon. This angle is 25 degrees, and what we want to figure out, we want to see what is the height of this castle. So this is what we are interested to find. This is our x. How tall is this castle? And what we know is that the distance between the boat and the base of the castle, so this distance is 500 meters. So if this distance is 500 meters, it's going to be the same thing here. So this is going to be 500 meters as well. So now we have our triangle here, and we are ready to do our work. So A, B, C. We have this angle A, so we label opposite, adjacent. So this is going to be hypotenuse, opposite the right angle. So again, we want to find the opposite, and we have the adjacent. So again, it's going to be TOA, tangent. So tan 25 degrees equals opposite over adjacent. Tan 25 degrees equals x over 500. And now we put this one over 1, we cross multiply, so 1 times x, or 1x, equals 500 tan 25. X equals, we use the calculator, 500 times tan 20, 233.2. 33.2 approximately meters, because dimension is also given to us in meters. don't forget your concluding statement. Therefore, the height of the tower is 233.2 meter, and you're gonna say like APP means approximately. Now a big reminder here that when we talk about angle of depression, it's when you look down, but the angle between the line of sight and the horizontal line. So make sure that you don't make a mistake about that. Okay, next example. A ship is 130 meters away from the center of a barrier that measures 180 meters from end to end. So there is here, which is 180 meter, and this ship is 130 meter away. What is the minimum angle that the boat must be turned to avoid hitting the barrier? So if this boat keeps coming, it will hit the barrier, or if it goes like this or like this. This is the minimum angle that it has to turn at least this much or even more to avoid hitting this barrier. Now, this is going to be our triangle. Now, if this whole thing, this whole barrier is 180, this is going to be 90 meter because it's half of it. If you think about it, it is half of this. Okay? It is half of this, was going to be 90, not degrees, but meter, 90 meters. So this, which is half of it, is going to be 90 meters. Now, we are going to again label A, B, C, and this time we are looking for an unknown angle. This is the angle we're trying to find. So this time we are looking for an angle. I'm going to put it out here, and I am going to label the sides. So this is the opposite, this is the adjacent, and then opposite the right angle is hypotenuse. Now we have opposite given to us, we have adjacent, and we want to find angle A. So an A means tangent, so I'm going to set up tan A equals opposite over adjacent. Tan A equals opposite is 90 meter, adjacent is 130 meter. Again, when you are trying to find an angle, you have to use the inverse trig. So angle A equals the inverse you have to use, 90 over 130, and you don't need to put the meter here. So inverse tan of 90 divided by 130, 34.7 approximately. So angle A is approximately 34.7 degrees. So then we are going to say the minimum angle is 34.7 degrees to avoid the barrier. Okay, let's finish with the last example for today. A helicopter is hovering above a road at an altitude or the height of 24 meters. So that's how high the helicopter is above this road. At a certain time, the distance between the helicopter and a car on the road is 45. So at some point, there is a 45-meter distance between a direct distance between the helicopter and the car, and we want to see what is this angle of elevation, meaning that if from here you're looking up at the helicopter, what is this angle going to be? So I'm going to highlight where the angle of elevation is here, this. So again, we are going to give name to the triangle, and we are trying to find this angle, which is angle B. So we will label with respect to this angle. This is the opposite side, so O. This is the adjacent side, so A. And this is the hypotenuse. Now, what we have is, we have opposite, we also have the hypotenuse. So opposite and hypotenuse are given to us, so we can use the sign. Sine, the unknown angle is angle B, equals opposite over hypotenuse, SOHCAHTOA. It's very helpful that you always write your SOHCAHTOA. So opposite hypotenuse, that means we're going to use sine. So sine B equals, opposite is 24, hypotenuse is 45. Again, we are trying to find an unknown angle, so we have to use the inverse sine button on our calculator. So 24 over 45. So inverse sine 24 divided by 45, 32.2. So angle B equals approximately 2.2 degrees. And you're going to write your concluding statement. The angle of elevation is approximately 32.2 degrees. I hope you enjoy the rest of your day. Stay safe until we have another lesson.